Today I'm going to talk about the classification of solids. The first is ionic, ionic solid. Now what is mean by ionic? As you can decode it from the word that ionic means ions. The presence of ions. So first we're going to read the definition. Solids that are formed by the presence of ion or a solids that have an ionic bond is known as ionic solid. For example, let us take the example of sodium. This is sodium atom. This is chlorine atom. Okay. Sodium. For example, 11 is atomic number, 2 electrons. Then 8. You can count yourself 8. And then 1 in the outermost shell. Unlike ammonia making the valence shell of chlorine, it has 7 electrons in its outermost shell. 1, 2, 3, 4, 5, 6, and 7. So it has a tendency to gain 1 electron in order to complete its octet, and in order to complete its sodium wants to complete its octet, and chlorine wants to complete its octet. So for that, sodium will donate a pair of electron to chlorine, and chlorine will get this electron, due to which it gets a positive charge, it gets the negative charge, and the attraction between them due to the sodium chloride fluid form. Sodium chloride. This is ionic bond. As you can see, this is the ionic bond. As you have seen, this you have NaCl in your daily life is the salt is NaCl. So this structure is something like this. Let me make it here. This is cubic in structure. Okay, this is cubic in structure. However, it is also polymorphism that we will be dealing as well. So NaCl example of ionic solid, which means there are ions, positive and negative. So let's talk about the properties of this. Let me read it. Let's read it. Properties. Property. The first is it is hard in nature. Now what is it? What does mean by it is hard in nature? So it is hard in nature. Okay, what does mean by it is hard in nature? So let's make a structure here. You know that this is sodium chloride. For example, this is ionic compound, right? Ionic solid. As you can see, there is no intermolecular spaces. You can see here this is negligible. This is a 3D structure or 3D crystal effects. But as you can see, there is no intermolecular spaces here, here, or here, or here, or anywhere. There is no intermolecular spaces, due to which it is very hard in nature. And that's the reason, maybe, yes, that's the reason it has high melting and boiling point. It has high melting and boiling point, and boiling point, and boiling point. It has high density, and it is not volatile in nature, yeah, it is not. One more property that we can use, yes, it is brittle in nature. Then I'll be telling as well what is brittle in nature. Okay, I'm including 2 points simultaneously. It is brittle in nature, and it is undirectional. Now what does mean by these 2 points? Undirectional. Let's deal with it. Okay, so arrangement of this ionic solid is something like this. This is cation, this is anion, this is cation. This is anion, this is cation. Anion is larger in size, but cation is smaller in size. So this is the arrangement of sodium chloride. For example, this now I'm gonna make. Oh my god, I need. Okay, wait. For example, this is 1. Then again, leave it. again small. This is something like this. In here we can say this is positive, then this is negative, this is positive, this is negative, and here for a while consider that I need dark color. I'm unable to change the color. Okay, now it's changed. For example, here also positive. For a while consider we don't know that this chlorine atom is surrounded by which sodium atom, whether it can be this, it can be this, it can be this, or it can be this. So that's why it is unidirectional or unidirectional in nature. It does not have any direction. And what mean by brittle in nature? Brittle in nature, when you're gonna apply the, oh my god, let me erase it. It's looking so messy. Okay, I need this. It's okay to erase it. Okay. Okay, let me erase it. Okay. So when I'm gonna apply the force from this side on this atom, for example, if I have applied a force like this, if I have applied a force here, so it will form a layer, something like this. After applied a form, it's left from its position, and so there will be something like this. Now, this positive, this I think this positive will come at the position of positive, then negative, then positive, then negative, due to which they both repel each other, and that's why it's brittle in nature. For example, when you take the example, for a while consider you have taken a salt, a very I can say a crystal of salt, and then you just apply a force, hit it with a hammer, you can see it break down into small pieces. Why? Just because it is brittle in nature. It usually break down into pieces when you apply the force. And ionic solid is usually arranged in this form, like this is negative, this is positive, this is negative, this is positive, then again this is negative, this is positive, this is negative, this is positive, this is negative. Now why the negative one is larger inside but the positive one is smaller? I have just told you the phenomena here. Let me tell you again. Positive, negative, and so on. This is the same, same structure throughout the same arrangement throughout the structure. Right? We know that when the higher sodium donates its electron and chlorine gains that, it usually gets smaller inside, while it usually gets larger inside due to gain of just because it gains electron and it loses electron. That's why we have the anion here, which is large inside, and cation is smaller inside. So this is ionic solid. Now let's deal with the other solid as well.